Hi everyone, welcome back to the channel. I'm Manisha. Today we are going to see retrieval augmented generation, that is RAG architecture implementation. In my previous video I have explained this architecture in detail. In case you missed that video, please check it out. I will also give the link of the previous video in the description box. Today I will start with a pipeline of RAG. I will explain it very quickly and then we will move to practical implementation of the RAG. So let's see. So now we will see the RAG pipeline very quickly. The first is user ask a question to large language model, and then next component of the pipeline is a list of documents. The documents might contain different types of documents, such as a Word documents, database, articles, or web pages. So here the system is going to use these documents to answer the question that user has asked. However, these documents have to be converted into vector database first. For that, documents are divided into smaller chunks. These chunks could be sentences, pages, or paragraphs, or lines, words, whatever. After that, these chunks are converted and represented into vectors database, meaning that these step transform textual data or text data into numeric format that can be processed by large language model. So this text conversion from character to vector or number is called embedding. So that is, in this case, is a content embedding, which is related to the external database. The next is like a content embedding that we see now. We need to do the embedding of the question that user ask. Therefore, simultaneously the user's question is also converted into a vector representation. This part is called as a indexing in RAG architecture. Now we have two things. One is a question embedding and the second is a content embedding. We have to do the similarity check between question and the content embeddings. What is that? The system checks the similarity between the question vector and the vector of the document to find top k relevant documents or information, which means that the chunks with the highest similarity score to answer the question. And why we need them? Why we need to check the similarity between question and content? It's because they are going to help the LLM to answer the user's question more accurately, and that's why we need a similarity check between two embeddings. So another thing that we need to do is to pass some system instructions to LLM. What is system instructions? They are used for how to answer the question. For instance, please provide a concise or accurate response, or these instructions can be please respond in a poem format, something like that. So then this bunch of things which contains content which from external documents, then system prompt is this one, and user question, this bunch of things will be passed to large language model to process. Finally, the large language model generates a response and answers the user's question based on the processed information, and finally LLM will pass that response to the end user. This is about the RAG pipeline. I hope the things are clear to you all. Now we will implement this RAG pipeline. It is a demo of RAG architecture. We are going to integrate RAG with the LLM. So before we start with the demo, I would like to mention few things. That in this demo I'm going to use OpenAI's GPT-2 LLM model, and for embedding purpose I will use all mini LM L6 v2 sentence transformer from the Hugging Face. So in this video our agenda is to see how to access the Hugging Face platform to access the LLM model that I mentioned, GPT-2. Then LLM without RAG architecture, what would be the response generated by the GPT-2 or LLM when we ask a question, and the same question we will ask LLM with RAG architecture. So in this LLM with RAG, we first load custom documents and then we will index them, then retrieval phase is there, and then we will generate the response from LLM. So first thing that we do is importing all relevant documents. So in here, pandas for data manipulation, request for web scraping, beautiful soup for parsing HTML and XML documents, transformer for natural language processing or LLM, sentence transformer for computing sentence embeddings. So it provides a pre-trained models that can this library provides a pre-trained model that can convert input text into numeric vectors, which captures semantic information. So as I mentioned, for embedding we are going to use all mini LLM L6 V2 sentence transformer from the Hugging Face, and there is a cosine similarity. It is a matrix used to measure the similarity between two vectors, in our case between question and content embedding. So another thing that I uploaded this code on my GitHub account. You can access the link in the description box. Hope it will be helpful for you guys. Then in this I'm going to run this first. So after importing all relevant documents, next is we need to get access of Hugging Face account to access the LLM model. So first is this kind of prompt will appear, and then you have to click on Hugging Face token. It will redirect you in the Hugging Face account of your account. Then you just simply click on copy token to clipboard and then come back again here, and here you will find one text box. Paste your token here and then enter. You just have to say yes here, and you are now successfully logged into Hugging Face account. I'm also going to create a separate video how to access or create an account on Hugging Face and access open source LLM model from there. So don't forget to watch my next video as well. Moving on to the accessing OpenAI's GPT model. So in here particularly, as I said, we are going to access the OpenAI's GPT-2 model, which is open source for the text generation. So I'm just going to run this cell as well, and then next is, it will take some time, and next is embedding model that also we are going to access from Hugging Face that I'm going to load. So you can read details about embedding models and LLM models later from the website. So first thing that I want to show you that LLM without RAG. So here is the code that I would like to run. So let's see the response generated by LLM here. Here we are asking a question: what is a Kolmogorov-Hernando theorem? And the we will check this function generator GPT-2. So first argument is question, then max length, and number written sentences. So what is question? Is the input text or prompt that we need to provide to the model. Then maximum length is the is a maximum length of generated output text in terms of token or words or subwords, and then number of written sentences. In this case I set 1. So number of different sequences the model should generate. Here I set 1, but I can make it 2, then we will have 2 different sentences. Let's check what would be the output. See, here are 2 different responses that we got, this one and there is second one. So if you set, we will set it again 1. Here you see this is the reply that we receive. Let us take the simplest approach. Suppose we take first 2 basic rules of mathematics and so and so. which I don't think it's really that accurate reply to answer this question. So let's go and check the LLM with RAG architecture. Now our objective here is to integrate RAG with the LLM. For that we need to first load documents, external documents to the system. So we are importing this web page related to the question, which is related to this theorem, and there are something the architecture is explained how to start with the cans, and all of these things are there. So I'm just passing one URL. You can go for the more than one, and also you can upload PDFs and other documents here, database for example. But here for this demo I'm just taking this URL. So I will run this cell, and using this beautiful soup library we are parsing this HTML page, and here is the code. And next important phase of the RAG architecture is indexing. So the first the extracted text blocks from the web page that we want to divide into chunks. So using these two lines, one line we have divided the web page into chunks. So the first line that we see here is hello can. So this one line you see here, and then the next line, then the next one. So we are basically we are dividing web page into chunks, and chunks can be sentences or lines or paragraphs. So in the next cell here I'm just converting the array into data frames to see them in a good format. Also I would like to see the embeddings, associated embeddings. So you see content, then this one. So as it is this thing is converted into data frame. Next is embedding. So now we need to apply embedding model to generate an embedding vector for each line, and I'm going to print that embedding to see the embedding array. So this is just the array, but now I want to see the content with its associated embedding. So using these, first I need to convert this array into data frame, and then I will join two data frames. One is about content and the second is its associated embedding. So you see hello can has a list of numbers. This is a vector of this content or line, and then this is the vector to represent this line. So that's how it works, the things behind. Now I just want to use or continue with the same question that we ask for the LLM without RAG. And so the question is, what is Kolmogorov-Hernando theorem? And I'm just reloading the question, and then after content embedding, this is important thing that we also need to embed the question. So this is to check the similarity between a question and content embedding, and so that's how we get the top k relevant documents to answer the question. So here it's a question embedding, but we are using the same model, embedding model, to do the question embedding. So this is the array that we have for the question. And the next important phase of the RAG architecture is retrieval. And here in this phase we will check the similarity between question and content embedding vector using cosine function. So let me run this cell, and we will check the top. I'm passing k is equal to 4, so we are just receiving top 4 similarity search or similar documents, relevant documents, and their indices. So we see second, third and sixth and fifth indices are relevant to answer the question. But what are they? So to check the lines, I just printed this. So we will see second. So this line is important or relevant to answer the question. Then third one is this one, and the fourth is not important according to this, and the fifth one is also important, and sixth one is also important. The rest you see there is no can related things, so they are not important. So I think this is working fine. And now we will just print those documents here. So these are the searches that we have. Now next is a response generation. So in the response generation we are combining retrieved documents to form a context. So first is the context. The second thing is a system prompt. So we are providing the instruction to the system that provide a concise and accurate response. So context is the top 4 documents or lines. The system prompt is instructions to the system LLM that provide the answer accurately. And the third one is combine system prompt as well as question and the context. That is top 4 document. And then finally the LLM will generate a response considering the prompt and return one sentence. You can set it here 2 or 3, but right now I'm just passing 1. So we will see the response from the system, and we will click on response, and here it's a response. So what is this? Is the question, and this is the answer that we got from the LLM, which I think very relevant reply that we have received. That's how you can integrate. This is just the demo. So that's all for this video. I hope you like this video, and I hope this content is useful, and thanks for watching the video. I'm also planning to come up with some machine learning algorithms and deep learning algorithms. So stay tuned and subscribe to the channel, and see you in the next